Developer Tools for Test Automation with Toni Solarin-Sodara.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Before we start, I want to put out a personal message. For those of you who have followed my work and content for some time, you know that I started ClearMeasure 10 years ago. We're a software architecture company, and that's the type of consulting we do to help in-house teams be great, to jumpstart them along their way. So all of our work is programming in all of its various forms, and we've done a tremendous amount of DevOps and cloud automation work as well. And we're the North American consulting partner for Octopus Deploy. Now, I haven't done this very often, but I'm putting out a call for anyone who'd like to work with me. We've been running on a backlog of projects for quite a while now, and we need to grow. We need some more .NET software engineers, DevOps engineers who have Octopus Deploy experience and Microsoft Cloud experience. And we're also in need of a few more experienced software architects. And if you followed me for any length of time, you probably understand how I think about software. And if you like the way I think about it, then you'll absolutely love working with me at ClearMeasure. We need to hire some people pretty immediately. So if this has piqued your attention, please go ahead and apply online on the website. And if you have any questions, just send me an email at Jeffrey, Jeffrey, at clear-measure.com. And thank you for indulging me with the interruption. And here's our regularly scheduled episode. Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results through its ClearMeasure Way methodology. Quick announcement. My architect forums are going strong. Signups for the next session are up. And so if you lead a software team and are looking to collaborate with peer architect leaders, then just go ahead and sign up at the link in the show notes. And for those looking for the Programming with Palermo video podcast, just search in any of the directories and you'll be able to find it. Now, my guest today on the show is Toni Solarin-Sodara, and he is a software engineering lead at Microsoft. He specializes in developer tools, working at the client platform layer, building the runtime libraries and tools that enable shipping code to various operating systems and devices. And Toni is also the creator and lead maintainer of Coverlet, a cross-platform code coverage framework for .NET with support for line, branch, and method coverage. Toni, welcome to the show. How are you, sir?
I'm good. Thanks for having me, Jeffrey.
Oh, my pleasure. My pleasure. It's a joy to have you on. You've done quite a bit of work at Microsoft, not only the runtime, but also various testing tools. And I want to ask you a lot about that. But before we get into it, for the listeners who might not be familiar with your work, would you mind giving us a quick background? What high points in your career kind of led you into this field and even led you to focusing on the tooling side of things?
That's a very interesting question, Jeffrey. So personally, I have always been a look behind the curtain kind of guy. When growing up and learning how to code, I kind of got interested in not just what I could do with the tools, but also how to build the tools. I remember this one time I was working on a Windows Forms app back in the day. And then I just got thinking, it's like, how are these drag and drop tools designers in Visual Studio made? How do I show the button? How is the button shown? When I click, what connects it to the back end? And that just kind of got me interested in trying to figure out how to build the tools that developers use. And I think I have been focused on that. I've been focused on that ever since.
Wow. And you've, as I understand it, you've done quite a bit, even contributing to the .NET runtime itself. Is that right?
Yes, that's correct. I thought that was interesting, so I decided to, And then there was this time when Microsoft was having its open source renaissance, basically, and then they just put everything on GitHub, and it was interesting to just peek behind the curtains. I never miss an opportunity to look behind.
Yeah. Now, tell us more about that area of the .NET runtime and specifically the native AOT parts that you contributed to. What went into that?
So a couple of years back, I was looking for more ways to contribute to the .NET ecosystem. I actually started by first contributing to the .NET docs. So then it was called docs.microsoft.com. Now it's called learn.microsoft.com. So I did write a bunch of different C# tutorials that is on that site till today. Then at some point, I figured I wanted to deepen my contributions. I wanted to actually write code within the repos that contribute to the .NET framework / runtime. So I spent some time looking through all the different repos that Microsoft had published on GitHub. I found the .NET Core repo itself, but it felt a bit daunting at the time because I was still very new to the whole open source thing.
Yeah.
Plus, my background then was more in C#, but a good chunk of the .NET runtime is written in C++. And then after more searching, I found this preview project called Core RT. It's archived now, but it still exists on GitHub. And it was this there were a bunch of engineers within the .NET team who were trying to revive some discontinued projects to make C# more of a systems programming language. So think of C# as more on the same level as C++, Rust, etc. And there was this super small, lightweight runtime that they were building that was somewhat separate from the main .NET Core runtime at the time. And I felt like this was something new. This was something fresh. There were not a lot of contributors. It was a lot more lightweight. So it felt like it would be the good start for me. So I started by, first of all, modifying code comments, because that's the best I could. Just working on PRs that just kind of changed the syntax slightly here and there before eventually going on to the first major contribution I did was adding support for F# compilation. I did not know what I was doing, but in the issues on GitHub, I had one of the engineers, the Microsoft engineers, who was always very willing to help. But at this time, I should mention, I hadn't joined Microsoft yet. I was not an engineer at Microsoft. This was before my time. And then, so after adding support for F# compilation, that got me a bit more familiar with the code base, a bit more familiar with C++. And then eventually I went on to do some more deeper things. So for example, one thing that I worked on that I'm quite proud of is being able to build native libraries using the technology. So the original use case for it was executables, right? You get the exits and you double click and it's all native, compiled to native machine code and everything. But there was also some asks from the community on the possibility of building libraries, purely native libraries that could be loaded by other languages, other platforms that were expecting to find the platform native libraries when it loaded stuff. And that was what I worked on. That was one of the major contributions I made. Eventually, the project went on to be fully integrated into the mainline .NET Core branch. And now it is being released as native AOT for .NET 7 and .NET 8. Nice.
And just for all the listeners, what does AOT stand for?
Ahead of time. So it means ahead of time compilation.
Yeah.
So in typical .NET is just-in-time compilation based. So this was more. So it's basically on the same deployment level as Rust or Golang and C++, where it's compiled straight to native code. No need for heavy runtime alongside the executable. So it was fun.
And what I'm also hearing, just an aside for anyone listening out there, is you contribute to one of the libraries or runtimes and get some pull requests accepted, you may get a job at Microsoft.
It was funny because when I was interviewing at Microsoft, I put Coverlet on my resume, and in one of my interviews, my interviewer was going through my resume and she was like, "Oh, you built Coverlet? I'm like, yes. Just like, oh yeah, we use it. So it was
Nice.
fun to know that the team I was joining used the product that I had built even before I thought of joining them.
Yes.
So that was quite interesting.
Yes. Well, let's get into Coverlet because I mean, I use it too. My clients use it. So many people use it all over the place because it's just so good. And now it's in the default test project template too. So I mean, how many developers around the world are using it now? But tell us, how did it start? Why did you think, you know what, this needs to be a thing?
I will tell you that it wasn't because I was super interested in test automation. That's for sure.
Mm-hmm.
I guess I was running off a bit of a high from all the contributions I was doing to the runtime, and I really wanted to solve even more complicated problems. And I saw an opportunity in .NET trying to be cross-platform. So for a long time, we had the .NET framework. .NET was perceived as Windows only. And we were at this point where Microsoft was trying to take .NET Core, make it run on other platforms. And I think from as far as the execution of your code side was concerned, that was fine. But the tooling was still very much Windows-centric. So I remember I used to pretty much exist on GitHub issues for various .NET projects then, trying to figure out what the community was asking for that Microsoft couldn't prioritize because they had other things that they had to focus on. And one of the things that struck me was code coverage. There was already an existing tool called OpenCover that worked with .NET Framework. It also worked with .NET Core, but only on Windows.
Mm-hmm.
And it's like, you're trying to, because at the end of the day, right, it's like you want to make the development experience for this new platform great on all the different platforms, all the different operating systems that people were going to build it for. So I saw an opportunity there to create a tool, a code coverage tool that worked with .NET Core and was also cross-platform, which is why it's one of the things that was called out in the title of the project. It's literally the very first thing. Mm-hmm. And it sounded like a complex enough problem. The reason is, so most code coverage tools in the .NET ecosystem use the .NET profiling API. At the time, .NET Core itself was still like the standard typical things running. You could write your hello world, you could write, you could build applications on it and it run cross-platform. But the profiling API was Windows only at the time, which is why OpenCover supported .NET Core but did not support. This is why OpenCover supported .NET Core only on Windows. Okay. It couldn't support it on other platforms because there was no profiling API type. I'm guessing it has changed now. I'm not too sure. So it felt like a complex problem, which was how can I achieve the same thing without needing to depend on the profiling API? And at the time, my work within the .NET runtime had got me interested and a little bit of experience into the world of compilers. So ultimately, I used very similar techniques with Coverlet, where it decompiles your application and then puts in all the different markers and then basically recompiles it back. And then you run it, and then the markers like report out into a file. And then at the end of the day, we read the file, and then.
So Coverlet, so you designed it to inject code into the code as it was being compiled?
After it had been compiled. So basically, it's like you C# code to intermediate language, and then Coverlet modifies the intermediate language to inject code coverage markers in there. So just before you execute it, the marker is already there. So that way, when it gets jig compiled and everything, it compiles the markers as well as your code. And then as your code is running, it's naturally getting the required metrics, storing them in memory, and periodically flushing them out to a file.
Okay, so is it inserting a line of code or a line of intermediate language code in every method so that it can say, okay, this line has been reached, or do you intersperse it between every line of code?
So Coverlet also uses their debug information to help its operations. So with the debug information, we can know what intermediate code corresponds to source code. So that tells us where to put in the markers. But yes, we basically instrument every single line of your code in every single method of your entire code base.
Yeah, because in Coverlet in the reports, you can tell if a branch of an if statement executed or not, even within a method.
Yes, Coverlet does it puts markers in every bit of your code.
Yeah.
If it's code you wrote that is in your DLL, it will put markers in it.
Now, what scenarios does it support really well, and which ones maybe for the future? Because it comes out of the box, and with the report and Azure pipelines can grab the Coverlet reports and display those. But what are all the common scenarios that it just does really, really well? Like it solves this problem completely.
Well, I guess mostly unit testing scenarios, because a good chunk of Coverlet is also the build system integration that we also need to automate things so that the work it does is as transparent from the user as possible. Mm-hmm. So like modifying your code is like the smallest, is like one of the smallest things it does. We also like integrate very deeply into MS Build, so that what happens is when your code compiles, we hook into the compilation, I guess, target or compilation method of the build system. So it's like once it gets compiled, the coverlet is notified, and then we run some build scripts to do certain modifications to the code base, to your code. So as you build it, it's actually part of the build process. And then after that, you go ahead and run your unit tests, and everything just kind of happens automatically. It's slightly bit harder if you've got like integration tests and you've got like maybe end-to-end tests that are not part of the unit testing infrastructure that you have in like .NET, mm-hmm. the .NET I or Visual Studio today. So that one requires a bit of more of a manual process. But we do have Coverlet has 3 packages. So we've got the MS Build package, we've got the console package, and we've got the collector package. So the console package is basically an executable that allows you manual control over Coverlet's instrumentation capabilities.
You make a good point. Integration tests, unit tests, the full system test. Oftentimes those are in different test suite, different test libraries, and they run, maybe they typically are run at different times. Even if they're run in sequence, they're still different runs. And so I guess you would get different reports. What's the process for taking multiple runs of multiple test suites and getting them into a single report, maybe in your Azure Pipelines dashboard?
Coverlet has a merge functionality. It helps you. So it's like we do not try to assume too much about your environment. And we assume the bare minimum to give you a good out-of-the-box experience. So it's like we pay attention to when you're trying to run your tests, your unit tests and everything, and we do the necessary collections. But if you have a bit more, if your testing pipeline is a lot more elaborate, there are command line options you can specify to MS Build that MS Build will then forward to Coverlet. So you can specify specifically that you can have it merge reports. So if, let's say your first run was a unit test, for example, we spit out the coverage.xml, the coverage.json output. When you're trying to run the integration tests, maybe that's the next stage in your pipeline, you can specify the previous file that was a result of the previous run and say, I want to merge the results of this particular run with the result into this file. So what then happens is that instead of Coverlet generating a brand new result, you just append those results and update the necessary results in that file. So that way your testing suite can be elaborate, but we can still provide a unified, we give you the knobs to still ensure that you can get the unified reporting.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient.
moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, Clear Measure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. Clear Measure, empowering software delivery. Clear Measure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
Yeah, that's fascinating. So if there's multiple test runs, you just keep on appending to the same file set. Great. And now when you're integrating them with other tooling, there's this other thing that's called Cobertura. How do those things relate?
So I think Cobertura is also a pretty popular code coverage tooling, but code coverage tool. I think it's mostly for Java though. It's been a while since I looked in, but I think Cobertura is mostly for Java.
Mm-hmm.
But the thing about tools is that when they become very ubiquitous, right, their chances are like infrastructures that are built around them tend to then have specific support for the formats that those tools kind of write to. So I know that there are lots of tools that know how to read the Cobertura report format.
Mm-hmm.
Visual Studio, Azure DevOps also supports Cobertura natively. So one of the things that we did early on in Coverlet was to have support for output into different other formats. So Coverlet has its own format, which is the coverage.json.
Mm-hmm.
But to help with interop, we also output in OpenCover format as well as Cobertura.
What's your favorite format? What's your go-to if you're just...
My format, the format Coverlet made.
Okay. And does Azure DevOps and other build servers know how to read that as well? Have you seen?
I'm not quite sure, but I do know that I have seen tools pop up, some Visual Studio Code that actually support the coverage.json format. Sometimes I just go to nugget.org and just put in Coverlet in the search box and see what comes up.
Mm-hmm.
So for example, there's the Cake build system. Some tools have been, so there's a package to integrate Coverlet into the Cake build system. There's a reporting, because our output is text, right? There are some tools that take that text and generate nice fancy graphs and charts and visualizations based on that. So there are tools that support Coverlet as well.
Okay. So now you're inside Microsoft, and of course you created this coverage tool, which is basically the de facto .NET standard tool now. I mean, when Visual Studio creates a test project, it's there, right?
Oh, yeah. Fun fact, so I did say we had 3 packages, the MS Build package, the Visual Studio Collector package, and the console package. The Collector package was contributed by the Visual Studio test team. That was not my creation. They did the work. There's like first-party support for Coverlet within the Visual Studio test collector itself, so that Coverlet can be kind of like a first-class citizen. So they did a bunch of work in the Visual Studio test runner itself to make Coverlet better, and then they created the created and contributed the Coverlet collector package. We still maintain that, but it was quite nice of them.
Yeah, absolutely. So it's used all over the place. What is your view on how the code coverage results should be used? Whether it's, go for 100% unless you have a specific exception versus some people advocate to learn what a good baseline is and then just try not to let it fall. How do you think about that? And so teams who maybe are not even measuring their code coverage, what would you advocate the right position to take is on that?
I think code coverage, understanding your code coverage is super important, but should not be looked at in isolation. So it's like not the only important metric of your code base, because sometimes you have a bunch of different abstractions that could make testing every single line pretty much impossible based off of the architecture of your code. So I'd say it's very much code-based specific, and as well as infrastructure specific. So for example, if you're doing unit tests, most unit tests, you wouldn't expect them to make network calls or actually modify the file system. You kind of like mock up a bunch of stuff. And if you've got code in your code base that, writes to actual databases or makes actual web requests, those will not be reported in the app because they are not hitting your unit test. But if you were to run like integration or end-to-end tests, for example, then it's the expectation that, those parts of the code will be exercised. So it's important to understand, to know what kind of test you're doing, to know if the code coverage metric you're getting is cause for alarm or is actually acceptable.
Mm-hmm. You brought up end-to-end tests, and I'll just take a simple scenario where maybe we're using a Selenium or Playwright to poke a button in a web browser on a simple web application, but the test runner in that case is in a separate process than the code being executed on the server. How do you get coverage results when the actual test project may be just running a Selenium API, but then the code you want to measure is running in a separate process, maybe on a separate server?
I think that particular scenario is slightly easy because the code coverage measuring tool is not external to your code. It's in your code. Even the code to write out the results to a file and to collate all of that is in your code. We don't just instrument every line. We also add some extra classes, some extra methods of our own design into your own code base. So it goes wherever your code goes. There is no external tool that needs to connect to, your code or anything. So I think it's just, the question at that point is, if your test is running on a different server, do you have access to that server's file system?
Okay.
Because you can configure where in the file system Coverlet spits out the result. Because we also listen for like runtime exit event. So we know when .NET is shutting down your code. And that's when we take the opportunity to kind of like flush everything as quickly as possible. We've got like 100 milliseconds or 2 milliseconds. I can't remember. So yes, so it's more of a question of like, do you have access to the file system on the server?
Well, let's take the simple case where it's running on your computer, but it's a separate process. If you're running unit tests in .NET 7, it's normally .NET.exe test, and then you add some arguments to where to spit out the file. But if you're doing .NET Run to maybe run a web application or a web API, do you just add the same arguments there so that the tooling knows to spit out the coverage file?
Yeah, so in that case, you would use the console package, and instead of directly running .NET Run, you will tell the console package to execute .NET Run for you. So the console package works by, you give the Coverlet console command the commands it needs to run to start executing whatever test it is you want to execute. So it uses that opportunity to find the necessary DLLs it can instrument, goes ahead to instrument them. But after that, it executes what you need it to execute and just like backs off and lets it do its.
So Coverlet console is the process that's running, but it wraps and it will execute .NET Run under the covers for the instrumentation. And then we can call the web service, call a web page, whatever we want to do, and we'll still get that coverage file.
And you also get the coverage file.
And then the same, and if we want that coverage to append a previous unit test run, a previous integration test run, it's those same command line arguments to feed in.
Yeah.
Brilliant. Because I can just see the chain going on here where you have unit tests and then you have integration tests and then you do something, you deploy to, a first environment, and then you have automated Selenium or Playwright tests, or maybe automated, web service calls or something, end to end, something disconnected. But it's your testing pyramid. It's cumulative testing. And from a numbers perspective, you want to know coming out the other end, is there any code that I literally didn't even exercise?
Yeah.
Oh,
Exactly.
it's brilliant.
So you can start from like simple unit tests to more elaborate tests, and at the very end, you can get everything collated into a single report, and then you can use whatever tool you have at your disposal to kind of visualize the report and see what's really happening.
Yeah. Yeah. It's one thing to know that some of your code is not covered and you're aware of that. It's another to be surprised that some of the code you spent time on literally never got called.
Yeah.
So, awesome. Well, before we kind of run out of time here, you've done other tools as well. And just looking at your GitHub account, you have another library called Pose. That was quite fascinating because, we've learned over time, put in an interface, make an abstract method, mark a method virtual, all kinds of things so that we can get a hook to test some things. But I'll let you describe Pose. What does it do and why would people find it useful?
So before I start explaining Pose, I should mention that I am no longer maintaining it. It is super hard to maintain, especially across different releases of the .NET runtime. Its implementation is a bit hacky, so doesn't always work quite well. But here's what I was trying to solve when I started working on Pose. I was thinking more of like, how easy will it be to sort of build a sandbox around your .NET code? So basically, it's like you've got .NET code that you do. I think it was also part of me thinking about, okay, .NET Core is going, it's cross-platform, but there are lots and lots of code out there that was still like .NET Framework, still very Windows-centric, probably don't even have access to the source code anymore. How can you find a way to ensure that it would work on like Mac OS or Linux without, issues? Because at the end of the day, right, it's like .NET Core may be able to execute it because it's still the same intermediate language, but the APIs it tries to call may be, very Windows-centric. And I think what I was trying to do was to provide a way to kind of sandbox those particular problematic code to say, I will provide my own implementation of this thing that you're trying to call that is not available on this platform that I'm trying to run on. As I started working on it, it just kind of grew out into this general like mocking framework. Microsoft does have a tool like that. I can't remember the name. I think it's called Microsoft Fix. Yes, but it's a bit more offline than runtime, like Pose was trying to be. So the general idea with Pose is that you can basically provide your own implementation for any class, any runtime. Any class, any method. So basically, if you were trying to run a test or there was a bug in some code and you wanted to provide your own datetime.now, you wanted to say, okay, whenever this piece of code calls datetime.now, to always return this specific date and time, you could do that. And that was actually with one of the very first things I tested when I was building it out. It was, can I make datetime.now be always this specific date and time? So how it works is you kind of enclose a block of code in a Pose context, which is just like a delegate. And then what happens, and then you get to provide your own schemes, your own like, okay, if any code basically you're saying while executing this block of code, if anything at all in whatever assembly, whatever binary or whatever tries to call this particular method, I want to run this other method instead. So that was what Pose was for. Again, it did something very similar to Coverlet. Again, I was super fascinated with like compilers and like the compilations at that time. So it did follow your code, it followed all the methods, it decompiled them. And then decompiled them, figured out where you were trying to call the method you needed to mock away, and then replaced it with a call to yours, then recompiled everything.
All right, so let me make sure I understand. So a regular developer not having on their computer the source code for datetime.now, it's a static property on datetime. And you're saying just basically wrapping that static call and saying, instead of calling that, I want you to return me back whatever date I want. It's going to modify the assembly, the IL, to make that happen so that you can write testing code that can depend on datetime.now returning your date.
Yeah,
or really any static method or property of any class.
Yeah, static, instance, whatever. And it's not, you don't even just get to wrap datetime.now. So for example, it may not even be your own code that calls datetime.now. It may be some third-party dependency.
Oh, yeah.
So you could even say, you know what, I have this block of code that is going to call this third-party dependency that will call this other third-party dependency, and that one could call datetime.now. When that third party, when you're like that 3 levels deep third party dependency calls datetime.now, I still want to return this exact date. So you could go as deep as you want. It doesn't actually have to exist in your code what you're trying to mock. It worked.
Yeah. Initially, what does it still work? Some of the scenarios there's been breaking changes, right?
Yes, because there's been changes into how the .NET runtime works.
Gotcha.
So it doesn't do well across different versions of the .NET runtime. I did make some more modifications to it sometime last year, 2 years ago, that actually improved its accuracy, but then I ran into other problems, and it's just a lot of work to maintain.
All right, so we have a call for maintainers. If anyone wants to maintain a open source library and then get a job at Microsoft.
But I have been asked about it, it's funny because even while I work within Microsoft, I still get people pinging me from within Microsoft asking me about what different things that I have built.
Well, it's fascinating for me.
Yeah, just I've not been able to get it to a point where I feel it can be super stable. Plus, there was also the issue of, because it basically like rewrites your entire call stack, things like debugging and whatnot isn't going to work. So if you put a break in your code, that's not the code that is executing anymore in memory. It's something completely different.
Right.
I had a different idea of getting that working. I was going to first decompile the code into expression trees, because expression trees in C# let you put in debug information and then like tack on. I mean, I just couldn't really find the time to really go as deep as I wanted.
Well, it's fascinating for me. And when I looked at it, it just popped out at me because all of the times in my career since the 90s where some code that either was from the outside and I didn't control, or it was sufficiently old and we were sufficiently scared of it, scared to change it and refactor, because there's great, refactoring techniques for inserting shims or abstractions or indirection. But if we really didn't want to change it, now there's an option. Now I can write tests to test my code, but have it stop at a certain point. Or there's this, third-party API out there that I don't want the testing to go all the way, and I have an option to say, okay, stop right here.
Yeah. Another scenario I considered in my mind was like basically like building like an in-memory file system. So you kind of like shim all the file system APIs and have it like write to some portion some array in memory instead of writing to the file system itself. So that way you could sort of encapsulate your code from the surrounding, when something tries to read a file that probably doesn't exist, you can just provide your own content to it as well. So it was meant to help you like set up this like fully controlled testing environment, both for your own code. I mean, for your code, it's easy, right? You have access to your code. You can modify it to do what you want. But it was more for like the code you do not have control over.
Right.
How can you also provide a controlled environment for it, such that if some piece of code was calling datetime.now, you wanted to like say, you know what, this datetime.now, I always want it to be this particular day, this particular year, this particular time, in order to help test the specific scenarios. So that was what it was for. I still think about it every once in a while. Problem now is I have a lot of responsibilities. I was a bit early in the career then, so I had time on my hands. Now the stakes are a bit higher. So,
and it sounds like some of the same techniques are from Pose and Coverlet are used. You're looking at the IL, you're deconstructing it, you're inserting some things, and you're putting it back together.
Yeah, I think at some point it was the techniques. It was the technique that kind of interested me. So I was just really doing any projects that required, I was basically just trying to solve problems that could be solved with that technique. It was just so much fun to like about people's code, modify it, put it back together and have it still run without issues.
Right.
Yeah, I like the challenge of it.
So it sounds like for any of the developers listening who are really interested in learning intermediate language and the mechanism by which code is compiled and then put into assemblies, these would be some two great reference code bases to learn how that actually works in .NET.
Yeah. And .NET provides a bunch of different avenues for that. It lets you generate IL at runtime and have the J compile it. So it leveraged that a lot. Mm-hmm. It also has it lets you reflect over metadata, over DLL metadata. .NET is actually pretty extensive, even as just like a programming language workbench. If you were trying to build your own programming language, .NET is actually a very extensive language workbench for that. Because it comes with all the type systems and everything for free. And all you really need to do is figure out how to generate this intermediate language. And sometimes you don't even need to figure out how to generate the intermediate language. There is something called expression trees, where it's just it's just classes and methods and whatnot that you call. And, it just, it does the figuring out for you. So
yeah, testing techniques use some hardcore engineering concepts. Fantastic. Well, Toni, thank you so much for coming on and sharing with us all about what you're doing with developer tooling related to testing and all the information about Coverlet and how it works and how it can be used, as well as Pose for those who want to kind of look into the IL engineering. So, yeah, thank you so much.
Yeah, no problem. Thanks for having me.
Oh, my pleasure indeed. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.